All right, so that in the previous segment, we talked about reasons why a nebula normally does not collapse and turn into a star. So it's going to need some help. The nebula is going to need some help in order to get it to collapse. Now, in order to understand why it would collapse once you give it a shove, I want you to think about a ball that has a radius r, and then let's think about what would be the force acting on a particle out here. So the formula for gravity is going to be F is going to be equal to big G m1 m2 and then divided by r squared. So that was the formula for gravity. So what would happen if this thing gets a little bit of help so that this particle now moves to here? So do you notice that the radius gets smaller? So what happens if you put a smaller r into the denominator of a fraction? What comes out? Something that is bigger. So if we can get this cloud to collapse just a little bit, the force of gravity acting on the cloud is going to increase. And if it increases, that's going to pull it in even closer. And as the radius gets smaller and smaller and smaller, the force of gravity is going to get larger and larger and larger. So all we need to do is take this cloud and give it a shove. If we can compress the cloud enough, then gravity can take over and start to pull it in and eventually turn it into a star. So what would be some mechanisms that could shove the nebula? So the first one is going to be the solar wind. A nearby star is going to give off a solar wind. The solar wind is going to be the debris basically that's blown off of a star. So that's going to be protons and electrons and radiation. And so that solar wind could blow on the cloud, compress it just a little bit, enough to where the radius gets a little bit smaller, then gravity can take over and continue to pull it in. Okay, another thing that happens in outer space quite often is these clouds collide. So you've got two nebulas that are going to collide, and then when they collide, they're going to be compressed a little bit. It's like taking two balloons and pushing the two balloons together so that individually each balloon gets a little bit smaller as you're pushing them together. So again, gravity could take over and continue to pull in the nebula. Another one is a supernova. So in a future lesson, we're going to talk about how do stars die. And so one way that a star can die is it can explode. So when it explodes, that's going to be called a supernova. And when something blows up, it gives off a shock wave. And when that shock wave hits a nebula, it could compress the nebula enough that gravity would take over. Okay, then number 4, okay, I'm going to talk about it now, but we'll cover it in more detail in unit number 4. Our galaxy, the Milky Way galaxy, is a spiral galaxy. So that means it's spinning. So if you had a top-down view of our galaxy, you would see it would have a galactic bulge there in the middle, and then coming off of it are going to be these things, and these are going to be the arms of a spiral galaxy. And this particular galaxy is rotating in that direction. So it's going around and around. Now these things here, the arms, are actually going to be called density waves. And as these arms rotate around the galaxy, they're going to be bumping into gases, and they're going to act like a bulldozer. And so that's going to compress the gas in front of the density wave, and that could trigger new star formation when that happens. All right, let's take a break. When we come back, we're going to begin with our cloud, and we're going to end with a star.